Hello guys, it's digitronixnepali here, and today let's look at some of the crucial difference between X17, X16r and X16s. So this is our X17 top module, and it has got all these algorithms inside, and let's look at inside it. So these are component instantiation of it, and the rule of X17 is plain simple. We just fed the output of first algorithm to the input of second algorithm. So let's look at it. So D in will be fed to the first algorithm, of course, that will be Blake, and the output of first algorithm is fed into the input of second, and that's BMW, and output of second algorithm will be fed into the input of first algorithm, a third algorithm, sorry. So this is Grostal, third algorithm is Grostal. So what we can see here pattern is that the algorithm arrangement of algorithm are all fixed, previously determined, and the output of first algorithm will be fed to the input of second, and that's it. That's X17. And so let's look at X16R now. So in X16R, what we do is the arrangement of this sequence, the sequence is not fixed and rather it's dynamic. So how do we do this? We look at the last 16 digit of previous block S. So this is our last 16 digit of previous block S, and according to this value we arrange the algorithms accordingly. So we have 4 here. So first algorithm will be KCAC, and output of KCAC will be passed to the, here is F, so SAP 512. So D in will be passed to the first input will be passed to the KCAC, and output of KCAC will be passed to the SAP 512, and output of SAP 512 will be passed to the input of Blake, and this arrangement will be determined according to the previous blockers. And this is more ASIC resistant than X17, but it has some disadvantages, like sometimes what happens is some of the algorithms get repeated. For example, Blake is repeated twice. Here are 2 zeros, so Blake is repeated twice, and there is 99, so SIMD is also repeated twice. So if these algorithms are repeated twice, then S rate will be dynamic too. So power consumption and S rate will also be dynamic, and it will be changing over time. What it does, it is not very hardware friendly, and if we get power consumption dynamic, then it is not very good for hardware, and we get the S rate also very dynamic, and we may not be able to calculate S rate precisely. So to overcome this problem, there is X16s, which is much more hardware friendly, and for that what we do here is we take the previous block as like before, last 16 digit of previous block as, and we shuffle it quite a bit, and after shuffling we get this value. For this input we get this value, and in this value there is none of the algorithm repeated, and every algorithm is included. So here is none of the algorithm is repeated here, and all those algorithms is included. So how do we get this value from this? To get this value, we just take first of all 0, 1, 2, 3, 4 like this up to F, and according to this value we shift the position. Like here is 4, so value of fourth position will be shifted to the first one, so 4 will be shifted to the first. Here is F, so the F position will be shifted to the first, so here is F will be shifted to first. Here is 0, so value of 0th position will be shifted to the first, and this is F, so F will be shifted to the first position, and so on, and we get finally this value. And after we get this value, the arrangement of this algorithm will be sequenced accordingly. So first of all, here is 2, so second algorithm, that is Grostal, will be our first algorithm, and 0, so 0, that means Blake will be our second algorithm. So output of Grostal will be fed to the input of Blake, and output of Blake will be fed to the input of JH, and so on. So let's look at its top module. So here is all these register instantiation. This shuffles that previous block S, and this is our top module that arranges itself according to that previous block S. So this is X16s. So thank you guys, see you later.